Good evening, ladies and gentlemen. This is going to be our final post on Chapter 2. We are talking about using the vertical angle theorem. If you're not sure what the vertical angle theorem is or how it works, go back and check out Intro to Proofs 1 and Intro to Proofs Continued, as that will give you the basics of not only how proofs work, but also the vertical angle theorem. So we're going to break this down easy, medium, and hard. So we're going to do 3 problems from the problem set starting on page 124 going to page 127. So we're going to be doing problem number 6, problem number 17, which if you remember was bell work from the other day, and problem number 35. Okay, so let's start with problem number 6. Now all of them, we're going to start off with a pair of angles. Now, I'm going to be honest with you, I am not all that concerned about what the angles look like, more what we say their measurements are. So here we have 3x degrees and 80 minus x degrees. Now, as we went over with the vertical angle theorem, vertical angles are congruent. Okay, so these two angles are congruent. What does that mean? It means the measure of their angles are equal to each other. Again, congruent angles have equal measures. So here, we can go 3x equals 80 minus x. Now, once we have that, as you can see here, just highlight these both in red, we go across right there, and both of those are equal to each other. So we set them up equal to each other, and then we just use our prodigious algebra skills, solve for x. So we use the addition property of equality. We add x to both sides. Now we're going to use the division property of equality. Important to understand why it is we're doing these things, not just because the teacher told us to, but because there are properties and laws and rules and theorems and postulates and all this other stuff that says that we can. So we get down, we get x equals 20. Now, we want to check our work, and lucky for us, checking our work actually goes ahead and answers question number 9. So what we want to do is we want to take this 20, and we're going to plug it back in there to the 3x and there to the 80 minus x. If we did this right, we get the same answer both ways. 3 times 20, 60 degrees. Over here, we go 80 minus 20. Oh, look at that, also 60 degrees. 60, 60, same and same, so we're good to go. Okay, so that's the basics. So now let's move on to something a little bit harder. So I'm looking at 17 here, and 17 is what we did for bell work on Thursday. So we start off, we have 3x, so let me switch back over to my pen. 3x plus 8 degrees right there. Over here we've got 5x minus 20 degrees. Not 5x minus 20 degrees, but 5x minus 20 degrees. And then down here we have 5x plus 4y degrees. Now notice this is a little bit trickier because we have that addition of a second variable. Now the process we go through is going to be identical. We're going to look at the relationships that are created here. We're going to use those to solve for our variables and for the measure of the angles. Keep in mind that we have to do both for this problem. So let's start just like we did last time. We know that those two are congruent. If they're congruent, their measures are equal, so we can set them equal to each other. So let's do that. We go 3x plus 8 is equal to 5x minus 20. So what we're going to do is I'm going to subtract 3x from both sides. Good old subtraction property of equality right there. And we get 8 equals 2x plus minus 20. Then going to add 20 to both sides. And we get, that's the addition property of equality, and we get 28 equals 2x. So now we're going to use good old division property of equality to divide both sides by 2. We get 14 equals x. Now there are two things we can do here. We know that if we're looking at this, I'll use green here, feeling a bit Christmassy, that these angles right there, the ones that I just crossed with green, are going to be supplementary. They're part of a linear pair. Remember, linear pair, adjacent and supplementary. It means that adjacent, so we've got one common side, two non-common sides, and a linear pair are adjacent angles whose non-common sides are opposite rays. Opposite rays form a straight angle. So when you have two angles put together that form a line, they are called a linear pair. Go figure. So, where does that leave us? Well, we could sit there and go like this. And there are two ways to do this. You need to figure out which one makes the most sense for you. I know that 5x minus 20 plus 5x plus 4y is going to equal 180 degrees. So I take these two right there and I go, okay, I know that those two are a linear pair. I can add them up, get 180 degrees. And I know that I have my x down here, 14 equals x, so I could plug them in. So that would be 10x minus 20 plus 4y equals 180. Before I have to multiply by 14, I'm going to make this as easy for myself as humanly possible. I'm going to add 20 to both sides. So I'm going to get 4y plus 10x equals 200. I'm going to then subtract 10x from both sides. So now I have 4y equals 200 minus 10x. I'm now going to plug in that 14. So I have 4y, erase that little squiggle, equals 200 minus 10 times 15. And by 15 I mean 14. And 4y equals 200 minus 140. 4y equals 60. Divide by 4, division property of equality, and I get y equals 15. So then I would go back, I need to find the measure of that angle anyway. So now I know that x equals 14, y equals 15. So then I go 5x plus 4y. Do all that substitution. I get 5 times 14 plus 4 times 15. I get 70 plus 60, or 130 degrees. I would also go back up here, plug 14 in right there, and that would give me 50 degrees. So notice 50 and 130, they do indeed equal 180. So we know we're right. Now I'm going to show you what I think is a slightly easier way to do this. But if this made sense to you, stop right now, fast forward a little bit, go to the next slide. So what I would do personally is I would sit there and I would go, okay, I've got my x there, 14 equals x. So I go up there and I find that that's 50. I know that that's 50, so I know that that's 130. Why they're a linear pair? Because I know that 50 plus whatever that is equals 180. So that's going to equal 130 after I subtract 50 from both sides. So now that I knew that, I'd go 130 equals 5 times x plus 4 times y. Not really sure why I put those parentheses there, but oh well, they're there, they'll stick. And then I know that I can just plug 14 in there, plus 4y. 130 equals 70 plus 4y. Subtract 70 from both sides. And I get 60 equals 4y. Now again, if you look, that's exactly where this was right there, so I know I'm going to end up with y equals 15. Personally, I think that's a little bit shorter, a little bit easier, and to some people a little bit cleaner. However, in teaching this in class, there were people who preferred that first way. So this way over here. So if you're one of them, that's fine. That's great. Nothing wrong with that. What's most important here is that you do what feels right for you. You need to make sure that you understand what's going on and that you're following those steps which make the most sense to you. Okay, so last one here. So I'm going to flip the page, look over at number 35. This is a beast. Okay, so we're looking at number 35 here. And you'll notice on this one that it's not just that we're going to have to absolutely, definitely find both of our variables first, and it's not going to be as clean cut as this. Here we were able to find x really easily right here by setting those two equations, those two expressions equal to each other. Not going to be that simple here. So let's fill this in. We've got 4y, 2x, and x plus y plus 10. Okay, so notice here, if I were going to sit there and swipe, let's keep it red. If I were going to sit there and swipe that across and say that those are equal to each other, I mean they are, but it doesn't really do us any good. I can write out 4y equals x plus y plus 10. But look, I got two variables there. I got an x and a y. At best, I could chart a line. There are an infinite number of possibilities there. So nothing doing. So what I want to do is I want to go ahead and see what my other options are. Remember, if you don't know what's going on, start writing down everything you know, see if anything pops up. Here, what I'm going to do is I'm going to write down also what my linear pairs are. So that 4y plus 2x equals 180. Unfortunately, that's not very helpful. And then I also have 2x plus x plus y plus 10 equals 180. Now, what I want to do here is I want to see if I can tidy things up a little bit. So that's going to give me 3x plus y plus 10 equals 180. Go ahead, subtract 10 from both sides. And I'm going to get 3x plus y equals 170. So I'm looking here, and I know that I've got to isolate a variable. Now, two variables immediately stick out. And that's this one right here, that y, and that x. Now, in all honesty, it doesn't really matter which one you choose to isolate. You're going to get the same answer. It works out. I'm going to isolate that x. Why? That's W-H-Y, not y the letter. Why? Because if I were to isolate this y down here, what I'd end up doing is subtracting 3x from both sides. So we get y equals 170 minus 3x. And I'm not necessarily adverse to dealing with negative variables. I just don't like it. If I can keep my variables positive, if I can keep my x's and my y's positive, I'd much rather do that. And that's what I can do here. So first things first, I want to switch these around. Symmetric property of equality. Remember that? A equals B. If A equals B, then B equals A. So I'm going to sit there, I'm going to go x plus y plus 10 equals 4y. Subtract y from both sides. And I'm going to get x plus 10 equals 3y. Subtract 10 from both sides. And here I am, I get x equals 3y minus 10. So I'm sitting there going, Mr. Renard, what do I do next? That helps me not at all. But it does. And here's what you're going to do. You're going to look down here, and you're going to see that 4y plus 2x equals 180. So I'm going to write it up here. 4y plus 2x equals 180. And hey, see that x there? This is where substitution was born, right there. Okay, so why this is important, you need to be able to go back to those dark days, that first semester of Algebra 1, and Sorry about that little tech glitch there, so there may have been some silence. I'm not really sure. I'll have to go back and listen to it. Anyway, what I was saying, substitution. So where we're going to start off is we're going to write that 4y plus 2x equals 180. Got that right there. And that is just using those two as a linear pair. I'm not sure what just happened there, but... Okay, so hopefully this is going to make sense. So I'm actually going to skip pages. We know that we have 4y plus 2x equals 180. We know that we also, hopefully this is still there from before, that we solved for x. Remember we had 2x plus x, or we had 4y equals x plus y. So we had x equals 3y minus 10. So what we're going to do is, see those two x's right there? They are equal to each other. So we can take this right here, plop it in right there. Plop being the highly technical mathematic term for it. Some people like to call it substitution. Plop is actually the right way to say it. So there we go, 4y, and then notice that we had an x here, an x here, and because x is equal to this, and that's an x right there, that means we push that x in. That is substitution. So now we get to use good old distribution. We get 6y minus 20 equals 180. We're going to combine those two. We're going to get 10y minus 20 equals 180. We're going to add 20 to both sides. 10y equals 200. Division property of equality. Y equals 20. So now we know that y equals 20. Good for us. We also know that x equals 3y minus 10. Hey, more substitution, or plopping, as the pros call it. We go x equals 3 times 20 minus 10. X equals 60 minus 10, or x equals 50. Okay, so now we have x equals 50, y equals 20. So now we can go back and we can solve for those angles. We know that one of our angles is 4y. Y equals 20. So that's 4 times 20. That's going to be 80 degrees. So if we go over here, this is this. This was 4y. So that's going to be 80 degrees. This right here was x plus y plus 10. We go back here. Okay, we know that y equals 20. X equals 50. So that's 50 plus 20 plus 10. Hey, 80 degrees. Check that out. What we have there, vertical angles, each equal to each other, so we know we did it right. Now, shortcut here, we know that these two right here are going to be 180 degrees. 180 minus 80 is 100. But let's just double check our math there, because that was a really simple one. That was just 2x. X equals 50. You have the proof right there. We go 2 times 50, and that is indeed 100 degrees. I hope this made sense. We went easy to hard. As I said in each of my classes today, one of the main things that people have trouble with geometry and switching over from algebra is that it requires a different thought process. You're not really doing anything all that different. This is all stuff you've done before. You've isolated variables before. You've substituted before. You've solved systems of equations before. You know this stuff. But this is applied algebra, okay? This isn't just sitting there, teacher giving you a message or a lesson and saying, here, solve this problem. This is kind of like advanced algebra. It's applied algebra. You're looking at this group of angles right here, and you have to figure out what those relationships are, how they work with each other, set up the equation. So not only do you have to solve the problem, you have to create it yourself. I know you guys can do this. Study hard. But you know what? Get some sleep. Got a test tomorrow. Have a wonderful evening, guys. I will talk to you later.